I'd hate to have to like go through
Yeah.
it. So
Yeah,
Okay.
seriously.
So question 3, are you there yet, Charity?
Almost I'm opening it up right now. I answered like 6 of them because I forgot that you guys are on a different time zone for a second there. I don't know where my brain was today. So I opened it up and I answered like 5 or 6 of them.
That's what we like to hear.
But I didn't submit it. So I don't know if I answered them right. All right, so number 3, yeah, I got the 3rd one.
Yeah, and then for the next one, I got the 3rd one too.
Yep.
And then I haven't looked at this one yet.
Yeah, a plot of residuals supporting using linear regression when. And I was confused, is it when like the distribution looks normal or is it when you see a pattern?
Let me look at my book.
Yeah, I was
yeah,
like,
something to do that now. A plot of residual supports using linear regression when.
Okay. I kind of think it's normal.
See, I thought it might be normal as well, but then I remembered that they had like the hot dog pattern. Like the hot dog pattern was normal, and then there was like the hamburger pattern or something like that, and stuff. So I was like, I don't even know.
I say we just put normal, and then between the three of us, we have 6 attempts, so not too worried.
Right?
Yeah, so it says on it says to check requirement 1, we do 2 things. To first make the scatter plot and to visually check to see if there's a linear relationship between X and Y. This has been referred to as a hot dog shape in the data. We want to make sure that there's no distinct curvature or other nonlinear characteristics. This is simply.
So it would be the normal one because the normal means it's hot dog shape.
Mm-hmm.
I think so.
Okay.
Dang, my computer's having a hard time today.
Saying no.
Yeah. Anytime I have to open SPSS, my computer has a hard time.
Yeah.
So.
Computing the residuals.
Gosh,
Analyze, regression, linear. I'm like, okay. Hey, does it ever like pull? Oh, there it goes. Oh, no.
Pull up blank, yes.
Yeah. And if it like close it and reopen it, and just a pain in the butt. Oh, no. All right, so we go to analyze, regression, linear.
Oh, I forgot to look which one was the dependent and which one was the independent.
Oh, yeah. The score variable as the response variable. Use the confidence variable as the explanatory variable.
The response variable is the independent, right?
Use the confidence variable as explanatory variable and the score variable as the response.
So the response is the dependent, right?
Yes. Because the response affects the, so in that case, the score would be dependent, right?
Mm-hmm.
And the confidence rating would be independent.
Okay, and then we have to go graphs.
Move the independent if you want to save the residual values.
All right. Okay.
All right, I got some answers here. See what I can do with them.
The hard part.
Right.
Okay, compute the residual for the data. What statement best describe the residuals?
Ooh, residual statistics. Minimum is 38, maximum is 94. So I'm gonna go, ooh. No, yeah, so I think it's the first one. Because it says the residual for a minimum is negative 38, the maximum is 23.4.
Wait, where do you see that?
If you scroll to the bottom of the statistics that you pulled up,
Yeah.
it should say residual statistics at the very bottom. Like, that's like the subheading.
Did I do something wrong?
I don't see that at all.
Okay, so what I did as well, it says if you want to save the residual following, if you want to save the residual values, you have to do the following. You have to click save, like when you're in that box, putting the dependent and independent samples in.
Uh-huh.
Okay. Sorry, let me get there.
So go back to that box
Okay,
and you have to click,
save.
yeah.
And then
And
you
then-
clicked the
So on the residuals,
unstandardized residuals.
yep, unstandardized residuals, it should be on the right.
And continue, and then,
Yeah,
okay. Cool. Thanks, Luke.
Yeah.
Unstandardized residuals. Okay. Yeah, I
Yeah.
totally forgot about that.
So I got a minimum of 38.19
Yeah.
that, and then
Yeah.
maximum of 23. So yeah, first one. Cool.
Yeah. Based on the QQ plot for these residuals, what can you say about these residuals? Ooh,
So hold on. So maximum. So it's the first one, and then sorry.
Crap.
All right.
Grammy.
I would say they look fairly normal.
How did you find the plot? Oh, did you make a plot?
Yeah, they want you to make a plot with everyone.
Ooh. I'm gonna go to menu. Oh, where's menu at? Dang it.
Are you on campus right now, Luke?
Yeah. I'm at work.
Nice.
Legacy dialogue, then scatter / dot. I am, yeah, so you can see it. I'm in the classroom teaching it. So
Wait, where are you?
I'm in the Clark.
Oh,
I
okay.
know where my folder is, babe. Oh, there it is. Sorry, my phone
Okay.
is dying. All right.
So what'd you put in the y-axis?
Yeah.
Did you put?
Sorry, hold on.
Does it matter?
I don't think so.
It
If
doesn't matter.
anything,
If
you'll-
plots.
Score is
Okay.
the Y, confidence rating is the X.
Yeah, that's what I put it right. Like the score is the Y and the confidence in the X, but I honestly don't think it matters because didn't they tell us it didn't matter once before?
I don't know. I'm sure. I don't care.
Where's my graph? Okay, whoa. It looks kind of normal, but it's definitely
Yeah.
scattered.
Right. Yeah.
Wait, like the thing that I'm confused about is they told us to like watch out for the like megaphone shape or whatever. And
Uh-huh.
it's slightly megaphone, but
Yeah, I would say they're not. I wouldn't say they're normal because that's a lot of deviation, you know?
Yeah, that's way a lot.
yeah. So I forgot what the options were.
Its residuals are clearly not normal, the residuals are fairly normal, or the residuals look right skewed.
I forgot what they look like when they're right skewed.
Yeah.
Oh, they're not right skewed. I don't think.
I don't think so either.
So I would just let's say they're fairly normal. Because there
I'm
is
gonna
still a line.
Yeah.
Like you can see it. It's just like maybe it's clearly
like,
not normal.
Clearly not normal.
Yeah,
would be
clearly,
like-
because clearly is a big word.
Yeah.
yeah,
Like it's in
most
the
of time
test.
when they-
Yeah.
When they say that, it looks like just dots everywhere, but this one definitely has like
some shape to it. All right, I'll put it then fairly normal.
Okay. So question 8, use software to create. So we've done that. Which of the 5 assumptions about the linear regression are satisfied by this data? Check all that apply. So there obviously is a linear relationship between X and Y, or else there wouldn't be like a
Graph.
question about it. Yeah.
yeah.
The variance of the error term is constant for all X, for all values of X. What?
I don't know.
Yeah, I'm gonna have to look that up in the dictionary. Variance of the error term. Variance of the error term.
The observation are observed and independent. I believe is one of them.
So the first one and the last one.
It's not normally distributed, so we know that one's not.
So the error, the variance of the error term is constant for all values of X, meaning the error would have to be the same on every X value. So we got the X and the Y.
I don't know. I kind of think it's the second one too, but like I honestly like don't remember this part very well.
I mean, we can just put our best guess and see what we get.
Okay, so it says for the requirements in the reading, it says for a linear relationship, you have to check it with a scatter plot. What you see, you should see a hot dog shape. For the normal error term, you do a QQ plot of the residuals, and what you should see is points in the QQ plot that are close to the line. So I didn't even put it in the line.
I didn't either. How do you do that?
You go back to the
What is it? Graphs?
Graphs, legacy dialogue,
Scatter dot.
define, and then what?
And then options. Ooh. No.
That looks confusing.
yeah.
Cancel. Did yours come with a line, Charity?
No, I know I've done a line before. Hold on. I think you might have to do this. Hold on. Let me check and see if this works. Regression linear, and then you go to plot.
So we're doing a QQ plot, not a residual plot, right?
Yeah, it's asking for a Q and Q plot. But I don't know what
But that is that a scatter plot though?
Well, it tells us in the book to do a scatter plot, so I'm assuming so, right?
Yeah, QQ plot.
Regression.
Matt, call your dad. He's calling me.
That means he tried to call me.
I have no idea what's happening here.
Yeah, I think that if we can't answer the linear thing, then we probably won't be able to know what the slope is either.
Yeah, I don't know how to. Ooh, you know what?
Playing my video game. Yep.
How do you solve for B1 again?
So I guess it doesn't really matter because we would know that the points are not close to the line because they're so spread out. So,
Yeah.
so it's definitely not the variance of the term is constant for all values of x, because that would mean that they were in a perfect line, right?
Yeah.
The x values are measured without error. We can't say that. They're not normally distributed. So maybe it's just the first and last.
Sounds great to me.
Okay.
What is a B1 estimate for the slope?
We have to find the line now, and I don't know how to do that.
SPSS, come on. Show me how.
Yeah. Yeah.
Because in the book, it shows that they got like the B1,
Mm-hmm.
but it doesn't show how to get that line or how to get that graph thing of all those answers.
All right.
Junk.
Okay.
You need the line to get the B1 score?
Yeah, because that's the slope.
All right, I'll have to just get talking.
I thought the slope was like on the confidence thing. Like
Or,
where it
okay,
says
yeah.
B.
Well, it's the y-intercept, or what the y-intercept would be.
It
is
represents the y-intercept.
B1. Yeah.
I thought the y-intercept was like B with the O next to it. B1 is just the slope.
No, BO is the slope. And B1 is the y-intercept.
So SPSS didn't give us a value for it.
Yeah, hold on one second.
Nova. Oh yeah, model summary B right there. I got it.
Wait, how'd you do it?
It's already on the sheet when we did it the first time. So if you look at the answers that you've got under variables entered for model summary B. Oh wait.
No, I was right. Like B1 is the slope on the regression line.
Where are you at? You're cutting out. I didn't hear anything you just said.
Because I looked it up on Google and I looked it up in the book.
Oh,
Yeah.
okay. I just wrote that down wrong then.
Sorry. So where? So
But
are
anyway,
you found it on SPSS then?
I looked up which one was the slope and which one was the y-intercept. Because I had it written down that B1 was the was the slope twice. So I just wanted to make sure I didn't get it wrong twice because I was like, oh. I thought that the B1 was like in the confidence part or whatever. I thought the B1 in this one would be the 12.695. But now I'm confused.
Wait, the what?
The B1 in this, I thought it would be not the 12.695, it would be the 7.28. The standardized confidence beta or coefficient beta or whatever. But now I'm confused.
Coefficients A. Yeah. So 18.690.
Okay, hey, who's picking this up from the airport?
I honestly can't
Now,
remember.
what kind of car are you?
Yeah, because I'm looking at the homework and I see where it's showing us conference reading. So I think it's going to be 12.695. Because in the homework it has in section 4.2, it shows here's an excerpt from the output of the managed data set, and it shows you this little thing with the coefficients A, and we have that same thing on the SPSS, and it goes and talks about the B1. And it inserts the B1 as one of the values that's on that same chart that we have on our paper. And so I would assume then that it's going to be 12.695.
Yeah, let's give it a shot because I knew that it gave it to us on the SPSS, but I couldn't remember if it was the confidence rating mean, like under the B, or if it was the standardized coefficient beta.
Mm.
You know what I mean?
Yeah. Yeah, it's not the
Let's do that.
standardized. It should be the unstandardized. Okay. Although 12.695 does seem kind of huge for a slope.
Yeah.
That's why I was wondering if it was the 0.7, whatever it was.
Yeah, 0.728. Maybe it is.
That's what I thought it was.
So on-
I honestly can't remember. So you put the 12 on, I'll put the 7.
Yeah,
And we'll see.
So on the book, if you look under 4.1, it gives you like the coefficient A, just like we have,
Uh-huh.
and it does, and then it makes the equation y equals negative the top number, so it'd be for us 18.690 plus
Yeah.
it has the
B1.
7.66. So I think it really is the 12.675.
Yeah, that's what I was looking at earlier too. So, but doesn't
Okay.
it seem like huge for the graph that we? Oh, you know what? No wonder it doesn't seem so big is because the graph we have, the numbers on the left go from 40 to 60 to 80 to 100, and the ones on the right are only
Yeah.
3. So yeah, that's totally right.
Yeah. Cool.
So it was 12.695.
695. Yeah.
Yeah, I just remembered when you said that, Alexa, how they were talking about like you have to look because sometimes it'll be like 100, but sometimes the graph will like skip by 1,000s, and like that's
Yeah.
how they're counting. So I just remembered that after you said that.
Yeah.
Okay, so how do we do the lower and upper bound?
We just did it with Luke, didn't we?
What?
Luke just had us enter the lower, like enter the information to get the lower and the upper bound, didn't he?
I thought that was our slope estimate.
Yeah,
The
that
minimum
was-
and the maximum, or
Oh, the negative 38 in the
yeah, isn't that
residual. Yeah. So yeah, negative 38 point. Negative 38.19. 0.120.
0.120?
Is that really the upper and lower bound for a 95% confidence interval?
I believe so.
That's huge.
There is like a big difference in between them.
So, thinking about that then, about the y-axis being so huge, going from 100 to 2 or 400 or whatever it was, 40 to 60 to 100 or whatever. So then that makes me think that the residuals are not normal based on that. If it was like a true value, if we got to really see the
Right.
plot. So I'm going to put clearly not normal, but just so I can.
Yeah, we can see what. Hold on, I need to.
I don't know though, because the upper and the lower bound have 0 in between them. And when there's 0 in between them, we fail to reject.
So the confidence interval.
No.
We didn't.
Reject. Sorry.
Wait, are you guys? No, it's not that. That's not the answer. It's not the 934.
It's not negative 38.
No. So we were supposed to go to analyze, and then regression, and then linear, and then there was a box that we checked for the 95% confidence interval.
Oh.
And so the lower bound is going to be 9.574.
Now, hold on one second. Is it an option?
I think so.
Oh, yeah, I put it. I just got it. So
Using the F value, is that what you're talking about? Or?
I didn't have to plug anything about an X value.
No, it doesn't want me to plug anything. I just.
lower bound 9.574.
Yeah, and then upper bound 27.807.
Are we supposed to use the constant or the confidence rating?
Yeah, it's a constant. I just looked at the book.
Okay. So sorry, that number one more time. What?
9.574.
Hold on one second.
And then 27.807.
All right. So 9. Okay, I finally got it. Sorry, it just took me forever. So the lower was 9.784.
9.574.
Oh, 9. Whoa. 9. 5. 27.
Yeah.
27.807.
Well, yeah. But
Alright, this is like an off week, you guys.
well,
I think it's because we're coming into the home stretch and I'm like, I'm really done.
Yeah.
Alright. Based on the evidence used in the level of significance of
yeah.
what decision should we make regarding the hypothesis test for B1?
I think it's the third one.
I'll ask Jay because Mom already called and asked.
Where did you find our p-value?
It's on the output.
Yeah. It's the sig.
0.00.
Yeah.
Yeah, it's the third one. And also they tell you like if 0 is not in between the confidence interval, then you reject.
Coolio. So for a hypothesis test, if you rejected the rejected the null hypothesis, what does that mean?
So there's sufficient evidence.
Woo!
Well, it's either the second one or the third one. I think
Second
it's
or
the
fourth?
last
It's-
one.
it's
Yeah, the
not.
last one. Yeah, not 0. So it's the last one.
Yeah.
All right.
Dependent is a body length. So I haven't even pulled that up yet.
Yeah.
So for 14, I'm pretty sure it's the body length because that's what we did last week too, right?
Yeah, the body length was the dependent one.
Yeah, I watched it.
My computer hasn't even opened it up yet, you guys. Sorry.
Yeah, mine's
either.
still
Here.
on the same boat.
Uh,
I'm on a boat and I'm going fast. And
what's that crud?
Yeah.
Okay, that was stupid. Okay.
Okay, so now we go to graphs or analyze, regression, linear,
The dependent is the body length, right?
dependent, yes, is the body length. Oh, Ooh, excuse me.
bless you, Chad.
Bless you.
And then make sure you go to plots. Oh, wait, cancel. Options.
Okay, so
Oh, wait.
Oh wait. I'm
It's
sorry, where are we at right
statistics.
now? Oh, we got to go to analyze, regression,
Yeah, linear.
linear.
And then make sure you press statistics and 95% confidence interval right then too. When you get
Which
there.
one is the dependent head
Body
length?
length. Body length.
length. Dependent head length, independent.
Yes.
OTE.
Okay. Yeah, this one is way more normal.
Yeah. Oh, did you make a graph too?
I didn't make a graph.
Yeah.
I didn't need it.
Oh,
So to find the margin of error. Ooh,
So it's the upper bound. So it's the
2.212.
2.212 minus.
are you guys on 15?
Negative.
Yep.
Yep.
Minus what? Negative 38 point what?
760.
760. That's a good area code.
So that's 20.486.
20.86.
20.
Is what I got, yeah.
20.486.
Yeah.
Yeah.
Nice.
So I'm pretty sure I'm right about how we have to look at the top one, but I'm kind of second guessing myself, even though I've read that book like twice now. So if someone wants to check it, that'd be cool too.
For the upper and the lower bound, or what are you
Yeah.
saying?
Because
Yeah.
it would make more sense to do the bottom one, but the book says it's the top one.
I believe it's the top one because
Okay.
I believe that we will win. Yeah, it says, yeah, that's what the
Yeah.
book says. The 95% confidence interval for the y-intercept is -50. Yeah, it's using the constant.
yeah.
Okay.
So
And
the lower bound was
-38.760.
Based
And then-
on, go
I
ahead.
think that's one's the bottom one.
There's insufficient.
I believe so.
Yeah,
Because the p value is greater than the
2.
alpha.
0.005.
So
Yeah,
it
and
would-
0 is in between them, and when 0 is in between them, we don't reject.
yeah. Okay,
So-
I'll submit it really quick.
Okay.
Fingers crossed.
Cross my fingers.
Okay, we missed. Crap.
Dang it.
That doesn't sound
So we
good.
missed both of the lower and upper bounds, like both the questions concerning those.
Really?
Yeah, so I'll tell you what we missed really quick.
Okay.
We missed question 8.
What'd you put it as?
I put the first and last one.
How many points did you get out of it?
0 out of 1. I don't think she's giving half points.
Oh, really?
And then we missed the 10 and 11. And then we
So
missed,
should we try the bottom numbers?
I
then,
guess,
even though it's
15,
supposed to
16, 17, and 18. So I would try the bottom numbers and see what, if that's just confusing to me though.
So for 7,
you guys still-
you put the residuals are fairly normal, though?
7.
That's what you had?
Yeah.
You
Mhm.
got it right.
Yes, sir.
Huh. Well, son of a gun, I shouldn't have exited out of that data.
I didn't exit out.
Oh, hallelujah.
I know I was about to, and I was just like, we might be needing this. So
Yeah, I exited out of the first one, but I still have the second one because if I have more
Okay.
than one SPS open, my computer has a fit.
Yeah.
So I'll read you what the first one is really quick. If someone else wants to submit it first.
Lower bound, I can do that. For number 10, lower bound is what?
Whoops.
Okay, let me
What
look.
was the
Lower.
estimated slope? Sorry, for number 9, I just totally erased it. Was it 12.574 or something like that?
Number 9?
Yeah.
12.695.
12.695.
Mm-hmm.
Sorry.
Question
No,
10.
you're good.
I'll,
Okay, so question 10. I guess 10.674.
10.
For the
6,
upper bound?
Lower.
Or for the lower bound? For the lower bound, I put 9.5.
Yeah, but they were wrong.
Okay, so what is the other one?
10.674.
10.67.
What's the upper?
Sorry, I got confused because I thought you said you did the 10 already. And I was
Yeah.
like, I don't even know
The
where you
upper
got
bound is
10.
14.715.
Okay.
And then,
15.
let me look.
95% confidence interval. So,
Okay, so that would be 7. Okay, so 15. Let me just tell you the lower bound first, okay? 218. So it would be 7.218 for the lower bound. And the upper bound would be 8.103.
and you're going to do the subtraction real quick.
Yeah, 8.103 minus 7. So I got 0.4425.
So 443.
Yeah, is that what you got too?
Wait, what was the upper bound and what was the lower bound? Because that's not what I got.
I'm telling him the other answers because we got them wrong.
Yeah, so I was doing determine the margin of error for the confidence interval.
Huh?
I thought we were on 15.
We are. We got 0.443.
4, 4, 3. Okay.
And then the sig for that one is 0, 0, 0. So
So I got 10 and 11 right. I got 16, 17, 18 right, and 15. So the only ones I got wrong was the question 8.
okay. Wait, what'd you put for question 18?
18, I put the first one. We were 95% confident that the confidence interval will contain the true value of B1. Oh, I guess we don't have to be live anymore, don't we?
Oh, no.
Okay.